Thanks, Lloyd, and thanks to the board and Lloyd for this opportunity for me to come home. Not a Wyoming native by birth, but a Wyoming native by choice. Lived in Wyoming for many years and worked at the university. Got a degree from the university and ended up going to work for a company whose senior management primarily graduated from the petroleum engineering department at the University of Wyoming. So this is old home week for me. And as I said, and as Lloyd said, we're here to talk a little bit about liquefied natural gas, which is a form of natural gas that can be used as a fuel. And we're not talking power generation exactly in this sense. We're talking transportation and equipment types of fuel usage. So I have to put this up. The Encana Natural Gas, Inc. is a subsidiary of Encana Corporation. We have a U.S. subsidiary called Encana Oil and Gas USA, and that is about 60% of the company. 40% of the company is based in Canada, where our corporate headquarters is. We're the third largest natural gas company in North America. Very familiar to many of you, most of you here in Wyoming, and very happy and proud to be partners with Wyoming. Encana Natural Gas, Inc. is a small subsidiary. 4 years ago, our CEO was Randy Erisman, and Randy could see the price of natural gas going down, and as he saw the supply going up. And so the issue was, what do we do to raise the demand for natural gas? And there's a variety of ways to do that. There's LNG export, there's power generation, increased industrial uses. It's been wonderful to see the plastics industry come back to this country when it was spending so much time in Asia due to the low price of gas there. But the other area that really was ripe for opportunity was the area of using natural gas in transportation and equipment. And what we're here today is to not talk about the small station or the individual car or pickup you might drive using natural gas, but what are the real diesel guzzlers? What are the things that really could move the dime and help us in a very quick fashion to use more natural gas, but not only to use more natural gas, but to provide a cost-effective fuel, more cost-effective than diesel? The company today, the small company, has LNG production. We do liquefaction. We'll have a definition here in a second, but liquefaction essentially is cooling natural gas. Minus 260 degrees and it becomes a liquid. If it warms up, it becomes a gas again. So you essentially are using the cooled gas as a means to get it from point A to point B. When it warms up, you use it as fuel in a gaseous state. We have mobile fuelers, you can see in the next box, and we have about 12 of those. Some of them can just transport the fuels. Some of them have a little pump up the back where you can actually fill a truck with it. This would be more of an 18-wheeler type truck. Some of them are regasification mobile fuelers that you can see. And regasification is when you take it into the field and run your oil and gas operations using that. Permanent fueling stations, we have one in Louisiana. One of the things we found is that when you're working with oil and gas industry, those rigs don't stay in the same place necessarily. And if you build a permanent station to fuel a rig, you may not have a need for it in a year or two or 20. And so the mobile fuelers have really become our view of what stations should be for the time being. And then the CNG fueling stations, we do have about 8 fueling stations. Encana runs one in Riverton. Wyoming has about 7 public stations that you can, public access stations, and you can convert many vehicles. You can use biofuel pickups that run either on gasoline or CNG, which is what we do in the field. So again, what we're dealing with is, I think you put up the PDF version. That's okay. The North American natural gas revolution, and I think we're preaching to the choir here as far as knowing the supply, but basically the horizontal drilling and fracturing has created from, in the right-hand side there, the bars showing from 2006 to 2012, an increase of 35. But the reality is probably much higher than that. You come down, the other key factor besides the supply and due to the supply is the divergence of the price of oil and natural gas. We used to be tied. We are no longer tied. And the multiplier is 20 to 25 times. Current fuel consumption, here's the opportunity, and this is US based. So in the US today, we use anywhere from 60 to 65 billion cubic feet of natural gas per day. The number up there on the left, you see 61 BCF a day. If we converted every vehicle, if we converted our rail, our shipping, oil and gas operations, we would double our usage of natural gas. That isn't going to happen in anyone in this room's lifetime, or perhaps anyone's lifetime, but it does represent a significant portion of natural gas that could be used, even at 10%, even at 5%. And if you look on the right-hand side, based on, and our data is from the Department of Energy as well as some analysis by Encana, we look to see a 3 to 4 BCF a day by 2022 usage in these sectors. Not earth-shattering, not really going to raise the price very much, but something that, when added to LNG export, when added to increased use in other areas, can be meaningful. So we have oil and gas, trucking, rail, mining that I'm going to focus on today. Not a lot of marine in Wyoming, so we'll let that go to other states at this point in time. This is a motion slide that actually would show you the light duty usage, the drilling use, rig usage, the pressure pumping services, and the supply chain that is a factor. But if we look at the colors, the red being our light duty pickups that can be converted to natural gas, the orange in the middle, the drilling rig, the pressure pumping or fracking equipment in the back, the supply chain being the trucks that are driving in sand and water, and the other materials that we might need to hold our operations. So when we talk about liquefaction, what are we really doing? You start at the well, you get the gas to a plant that cleans it, that then liquefies it, as I said, by cooling it. You put it in a truck, and you take it, whether it's back to the rig in a regasification mode or on to other sources where you're filling a tank. So in our supply chain, what does that really mean? How much gas are we really talking about? And it's hard to quantify that because you don't know how much each truck really carries or the distance that they've gone while they use the liquefied natural gas. And this is using it as their fuel, displacing diesel. But if you look at the drilling rig operations, we're seeing a number 90 to 175 truckloads. So down to completion or our pressure pumping, fracking, 800 to 1,200 truckloads. That's where really the most of the fuel is used, so the opportunity's right there. Drilling out, completion, small amounts, production, small amounts, but still material. So our options are not just LNG, but we really can use field gas, we can use compressed gas, or we can use liquefied. There's some things here that'll show you why you would choose one over the other. Obviously, field gas is right there, no transportation cost. Sometimes it's clean, sometimes it's not. That can be problematic. It is the lowest cost by virtue of the transportation. Compressed natural gas, good mobility, requires compression, limited by the volume. That's the biggest thing with compressed natural gas. You just need so much physical volume to hold the gas. Then you move to liquefied natural gas, you've got the mobility, you have to vaporize it to use it, but again, the regasification trucks take care of that. It's a high quality fuel and you're able to port it. Yeah, the mobility of it is much better. You don't take as much physical size for the fuel. So real quickly stated, the green dots are good, and if you look at LNG, it's good on cost, mobility, quality, and the environment. Going to field gas, you've got good on savings, not good on mobility at all, and then sort of a toss-up on other things. Dual fuel, where you use both diesel and natural gas, you really are looking at supply as being the biggest benefit. Mobility certainly is there as well, but a definite negative on the environment. The diesel being negative on the environment and the savings, but obviously for mobility, supply, quality, diesel's the fuel that's been used for quite a while. So we used field gas in Jonah, and years ago, probably 7 to 8 years ago, we had an environmental issue where we were not, the air quality was not what it needed to be, and we needed to do something in the Jonah Field. What we did was begin to run the rigs on field gas. And we've been continuing to do that to this day. Our 5 rigs there now today are running on field gas. The field gas is because it's there, it's been working for so long before LNG was even an option, that it doesn't make any sense to now go back and install an LNG solution. But bottom line is we had to improve the air. The results were that we lowered NOx by 85%, reduced haze, and saved $45,000 per well in fuel costs. And we learned a lot. We've learned a lot that we've taken all over our production. Trucking is the next, or part of this story, but to extend it beyond oil and gas operations, we have a few of these slides in each of the areas that I'm talking about. And I just really want to point out the mix of where in this area, this sector or category of transportation, the fuel and oil costs sit. So you can see the bottom circle, 39% of fuel and oil costs for a truck, an 18-wheeler type truck, are in fuel and oil. So there's a big opportunity to make a difference. The least benefit on a gallon basis, so if you have a diesel gallon equivalent of LNG, you're able to save at least 25%. And it's often closer to 40% just on the fuel cost itself. It's a cleaner fuel, cleaner running in the engine, so there are some benefits there. If we take a look at the highway of trucking, and the thicker the blue, the more trucks are there, you can see where you're going to need LNG stations, where you're going to need supply for trucks. A lot of it in that south central, southeast area. That Highway 40 is huge, but look at I-80. And we all know that. The trucks going through I-80 are really tremendous. We already have 2 LNG plants underway, actually ready to go, one in the Evanston, Rock Springs area and one in Cheyenne, that will connect enough stations for trucks going across I-80. The companies also, Clean Energy owns those stations. They've got a map of about 150 stations to overlay these blue lines and be able to create a grid. There's also a company named Blue that has its own regional Rocky Mountain grid identified in another company. Alt Fuels is doing the same thing. Shell is getting into the game pretty big in Canada, moving down into the US as well. Just so that you can see that there are options in the trucking side, we have 8 different types here. We have another 7 here. These are all, except with the exception of 2 of the first trucks, Class 8 heavy-duty big trucks, the kind of trucks we need in our operations, and frankly in other operations as well. Engines, a lot of 15-liter, 12-liter, 10-liter, 9-liter. We really are well served in this market. The downside here is a $60,000 upcharge in getting this truck. So you have to have significant fuel usage to offset that. Those prices will come down. They have not started to come down dramatically yet. So what is Encana doing as a trucking customer? Freeman Water Resources. We started with them in Louisiana, and they are running, I think they're up to about 50 of their Class 8s and have plans for 100 of them to be fueling. And there are water haulers in Louisiana. Definitely seeing the cost savings and going forward with more conversions. Locomotives. This is a fun one. 148,000 diesel gallon equivalents per year to run a locomotive. Comparatively, a mine hauler truck that would be 2/3 of what a mine truck uses. 6 semi-trucks would equal that, 160 passenger vehicles. So if you want to, again, look at maybe, and obviously no locomotive is paying $4 gas, but let's pretend they are, or diesel. If they're going to pay $3, they're going to save a significant amount of money that they can also attribute then to being cleaner burning within the engine. Back to the chart that shows you percent of fuel, the cost to run the railroads, $37.5 billion. Of that, $11.3 billion is fuel. Again, material. So what is Encana doing? We have a current pilot project with CN Rail up in Canada. We have a couple others I can't talk about yet that will be announced in the future. You have 7 major railroads. And if 1, 2, 3 start to do this, you will have 7 major railroads doing this. So this is something that's on its way to happen. Mine hauling. We have mine hauling trucks using LNG in Gillette area, Powder River Basin. Alpha Coal is using them. They're very pleased with what they're seeing. This is essentially that same slide as earlier. If we look at in the mining, the averaged cost to produce coal, fuel, and lubricants 12%. So again, another significant savings. We haven't even talked about the fact that some of the equipment in mines, maybe even trona mines, could be converted to LNG. So that wraps up a little bit about what Encana is doing, but I wanted to talk about a task force that I'm on with several other groups, and you can see that Governor Meade started this task force probably last March or so. People from the governor's office, the Business Council, School of Energy Resources, oil and gas companies, pipeline, mining, engine and vehicle manufacturers, plant and equipment design build, and then our consultant firm is Gladstein Anderson Associates, who's worked in this field for a long time. We have, as a group, joined to have GNA undertake an LNG study. Governor Meade will be speaking next week in Chicago as the opening presenter to talk about Wyoming's LNG plant and the fact that Wyoming is doing this study to really understand how Wyoming can not only use LNG, but can be a major liquefaction source, regional distributor, and use it here in Wyoming. We have 2 liquefaction plants already, a fairly small one in Painter, and another one, a medium-sized one in Chute Creek. The LNG stations I've already mentioned, the rigs in Jonah I've mentioned, and the Alpha Coal trucks. Encana, and this is my last slide, has converted 58% of our rigs on our way to 100% as makes sense. Sometimes it just doesn't make sense. And again, 20% or 28% of our fleet, like pickups and trucks and that type of thing, are converted to natural gas as well. One of the differences this time around, we've had supply of gas before, we've had natural gas vehicles before, we've used natural gas in other ways for transportation and equipment, but never before has the oil and gas industry gone to the lengths that we're going to now to convert our fleets and convert our equipment and to follow what we're telling others to do. Thank you.